Welcome everyone to this presentation of the performance of the new TURNkey network in Iceland during the 2021 Reykjanes Peninsula volcano-tectonic unrest. I would like to acknowledge the contribution to this work by my colleagues and collaborators at the University of Iceland, Gempa in Germany, the SEAM in Telecommunications in Iceland, and all partners of the TURNkey H2020 project, and the Icelandic Meteorological Office, an official third party to the project. Now, Iceland is the most seismically active region in Northern Europe. The interaction of the extensive mid-Atlantic ridge, the plate boundary between the Eurasian and North American plates, and the Icelandic hotspot under central Iceland has created an east-west offset in the plate margin, forming two major transform zones: the Reykjanes Peninsula oblique rift and the South Iceland seismic zone in the south, and the Tjörnes fracture zone in the north, respectively. The vast majority of tectonic strain release in the Reykjanes Peninsula in the south is accounted for by transform faulting on a bookshelf system of north-south striking vertical transform faults along the Reykjanes Peninsula, before thought only to be characteristic of the South Iceland seismic zone. Volcano-tectonic events are rare in the Reykjanes Peninsula, but contribute episodically to the release of tectonic strain through extensional faulting or magmatic intrusions. As a part of the TURNkey H2020 project, a new network of TURNkey multi-sensor instruments was deployed in the extreme near-fault region in the transform zones. The purpose was the consistent monitoring of earthquake ground motions for earthquake early warning purposes, and the densification of existing urban strong motion arrays. The regional development had been completed by mid-February this year and continued by the urban array station deployment in the spring. The deployment addresses particular weaknesses in the existing SIL network that continuously records ground motions and allows for the optimization of earthquake early warning protocols. Together with the SIL network, the National Seismic Network, a complete near-fault seismic and volcanic observatory has now been established in the southwest volcanic and tectonic region of Iceland. The real-time workflow of the new network is as follows. The CAPS, or Common Acquisition Protocol Server system, is active both on the TURNkey multi-sensor units themselves and the local SeisComp server in Iceland. It delivers the data with minimum latency to the local server using wireless telecommunications optimized by the Siemens telecommunication company. A SeisComp picker monitors and detects incoming phases and amplitudes. The ScanLog module locates the event that is optimized for earthquake early warning purposes. The Presto algorithm for earthquake early warning has been implemented in the SeisComp system separately for independent earthquake early warning evaluations. Finally, the QuakeLink module integrates solutions from SeisComp and Presto and proactively forwards event and station parametric data to the engine of the TURNkey platform for post-processing. The regional deployment of the new TURNkey network, represented by the triangles in the left figure, is optimized for earthquake early warning in the transform zones. It allows the real-time monitoring and detection of small and large events in the selected areas near the capital region of Reykjavik in the south and around the town of Húsavík in the north. The expected delay times to locate events and to compute magnitudes are about 10 seconds, depending on the location within the network. That is compared with to less than 5 seconds of the national seismic network coverage in the same regions. But with the inclusion of selected SIL stations in the South Iceland seismic zones into the TURNkey network, the earthquake early warning delay time is improved. This is a zoom-in figure for the TURNkey network detection times. Left is the southwest network, and the right is the northern network in the transform zones. And notably, the network in the south contains a small aperture array near Grindavík, and that was a new installation for a specific purpose. Now, the regional turnkey multi-sensor unit deployments in the south and had effectively finished by mid-February 2021, this year. Fortunately, as it turned out, as in light of the intense seismic sequence that started on the 24th of February and was well recorded by the TURNkey network. It provided a comprehensive test of the instrumentation, real-time wireless data transmission, and real-time processing of the local Seiscom system. It started with a magnitude 5.7 earthquake at the northeast end of a northeast-southwest striking extensional fault, with a seismicity moving gradually towards the southwest, as shown in this animation, based on the TURNkey network locations. Therefore, a 6-station urban array was deployed in the town of Grindavík on 12th of March for the purpose of using correlation analysis on seismic signals to provide additional information on the real-time location of the front of the dike intrusion as it advanced to the southwest, edging closer to the town until it stopped about 6 kilometers from the town when the volcanic eruption started a week later on 19th of March. Now, the system detected approximately 10,000 earthquakes since it went fully operational on February 26. After 7 earthquakes, larger than magnitude 5, in the duration from 24th of February to 14th of March, the seismicity reduced markedly and reached its lowest levels when an eruption started in Fagradalsfjall on 19th of March. The eruption is ongoing at present, with even lower levels than shown at the end of the top of the figure of seismicity currently. Therefore, the principal dataset used for the performance evaluation is that of the approximately 3-week period before the eruption. With regards to real-time data streaming, the mobile network plays a huge role in providing as much transparent data pipeline as possible to the TURNkey system. The investigation of the TURNkey partner Síminn Telecom in Iceland has shown that 4G and LTE-M, which is an IoT communication standard, comply fully to the data transfer demands of the TURNkey multi-sensor units. 3G has in some cases been used, but latency is not as good as for the 4G. The implementation of the CAPS system made a noticeable positive change in performance, like the graph shows to the right here, but there's always room for improvements. It is possible to get a better connectivity by using a lower frequency or by increasing the number of mobile nodes, both of which are what we have done here in Iceland for the 2 test zones, and additionally in the eruption area. The low latency of the system allows fast detection and earthquake magnitude and epicenter location convergence, in particular in this region. This is showcased by this playback of the screen recording of the 14th of March 5.4 earthquake as the data is arriving into the local Seiscom system. It shows a relatively fast magnitude and location convergence. The convergence of the event parameters are shown in these graphs for the same event as before, to the left, and one of its aftershocks of smaller magnitudes. It shows how the estimates improve with increasing number of phases that arrive into the system from stations further away, and the time after the origin time. However, the magnitudes can already be used only a few seconds after the origin time by the Presto algorithm and the TURNkey platform for post-processing of near real-time earthquake effects and impact estimation, such as Bayesian shake maps, infrastructure damage ratios, and loss estimation. Then, less than 2 minutes after the earthquake's origin time, the actual peak ground velocity measurements, for example, from all stations are fed into the platform, enabling iterative and revised estimates, along with other parameters. Now, to conclude, we have taken advantage of the intense seismic sequence due to the volcanic unrest in the Reykjanes Peninsula in southwest Iceland during the spring of 2021 to demonstrate comprehensively the performance of the TURNkey ground motion monitoring system in this testbed of the TURNkey project. Optimized by the wireless telecommunication of real-time data and the real-time processing and analysis of the local and central Seismic system for the purpose of preparing parametric data accessible for the TURNkey platform. While COVID initially delayed the original station deployment plans, most stations were deployed before the rare volcanic episode that provided multiple new opportunities, including additional urban array deployments. The deployments will be finalized this fall and constitute a marked improvement in continuous ground motion time history monitoring in the transfer zones of Iceland. With that, I'd like to thank you for your attention.